Hello, and welcome to CS54, Discrete Math and Functional Programming at Pomona College. I realize the semester has not started yet, but I want to get a head start on videos because this course is going to work in what's called a flipped way, where I will post lecture videos, and then in class time, we'll just have sort of a glorified lab where we'll all work together and watch videos sometimes, and it'll be a lab, and we'll do other stuff like that. So this is the introductory video. I'm Professor Greenberg, Michael Greenberg. I will be the sole instructor for this course. We have four wonderful TAs who you'll get to meet in time. Okay, so I wanted to just briefly go over some syllabus stuff, make sure everybody knew where everything was, all of that jazz. So let me shrink myself, and then you can see my computer. A lot of lecture is going to take this form, where I'm a tiny person in the corner of the screen. Don't worry, I'm actually full size. And then I'll have Emacs. This is the program we'll be using to write code in Coq. And then occasionally I'll have a web browser or something like that open to show you what we have. So I've got the course website here. It's a little hard to see, but if you go to my webpage, you'll see it. You should have gotten an invitation to Zulip and an email from me to get there. So in here are all the various things that you'll need. What I want to zoom in for now is the syllabus. We'll pop up in a second and look at our schedule. So if you go to the syllabus, it has like the usual stuff. It talks about me. It lists our wonderful TAs. It talks about Zulip and the software that we'll need to get installed. I'll have a video coming out next about how all that software works and what it looks like. Other important information, sort of how grades will break down, how homework gets turned in is via Gradescope, which you should have also gotten an invite to. If you can't access this, please let me know. The late policy, which is that we don't accept late work, but we'll look at it with you. And then at the very, very end, there's a paragraph that's very important that you read, which is so important, in fact, that I will read it out loud to you right now. This is the fourth run of this course. So CS54 has been taught 5 times, 4 times with this curriculum. And I've made a bunch of changes this time. So it's going to be a little different. Things went okay in the past, and I think they're going to go better this time. But it's a crazy, awful time. Right, it's just going to be really rough. So the deal I'd like to make is if things that I'm doing aren't working, I will change them and try to make them better. And if things aren't working for you, you have to let us know. So what does not working look like? Not working looks like you're not able to finish the homework. You don't understand what anything means. None of the software works. You're feeling detached. All of those are ways of this course not working. So if any of those things start happening to you, you've really got to let us know. Okay, so let's go back over here. How is the course going to work? Well, everything's broken up into days. So every day is sort of a chapter of the book, and that day is a homework. The homeworks will be due at the end of the week on Sundays at 4 p.m. Pacific time. Most grading is going to happen automatically. That is to say, we're going to use a program to grade your programs. There are pros and cons to this. One of the pros is you get immediate feedback on turning it in. You can, of course, turn homework in early. You can turn it in multiple times. All that's fine. One of the downsides is computers are sort of like notably hard-assed. Like computers are very intolerant of bad inputs. So what that means is if your code doesn't compile, your grade will be a 0. And there's really no wiggle room here. It either compiles or doesn't. So the thing to do is to submit earlier rather than later, right? You don't want to be submitting at 4 p.m., discover your code doesn't compile on our servers, and then now you're out of luck. So you want to sort of test it out and make sure it works early. And then if you get stuck, go on Zulip and ask us about it. Okay, so in a given week, on a Monday and Wednesday, we'll have 2 files, and they'll both be due at the same time. The course is broken up into 3 parts. The first part, these 10 class days, 5 weeks, these will be just learning how to program in the language. The next almost 5 weeks will be using the language to do proofs about the programs we've written. Right, all of this will be in the programming language we're using. And then the last bit, these 4 weeks, we'll be doing just proofs on paper, nothing to do with the programming language. Between each section, we'll have a take-home midterm, and at the end, we'll have a take-home final. And these will be due sort of the day after. So normally things are due on Sunday, so the midterms themselves, which are just going to be souped-up homeworks in some sense, will be due on the Mondays. Okay, you should feel free to look at these ahead of time, and it's all sort of written up. Not these, but all of these are written up. We do reserve the right to change these though. So I would not advise that you do the homework in advance, because I might change it and make the stuff that you did optional, and then add new homework that you didn't do. So it really pays, like, you're going to want to the week of is when you do the homework, but reading is just fine. Reading ahead will not hurt at all. Okay. All that is sort of logistical. What is this course about? Well, so the syllabus has a little thing from the course catalog, which we can look at, right? A combined course on functional programming and formal proof. Students write programs over a variety of data structures, proving their programs correct with respect to precise logical specifications. Programming topics and proof topics range over recursion, induction, combinatorics, algebraic data types from lists to trees to abstract syntax trees, structural induction, parsers and interpreters, soundness properties, regular expressions, set theory, and language theory. So we're going to cover most of those topics. This is sort of some of these we'll not particularly talk about. Some of these we'll talk about in great detail. This is a course about thinking extremely clearly about the programs that you're writing. You may think that that's what you're already doing, and that's great. And we're going to think even more clearly than you thought we could about programs. The goal of this course is to make sure that everybody has sort of a shared foundation in understanding what constitutes a good program or a correct program, how to think about programming, and we're going to do it in this sort of rarefied, abstract atmosphere of what's called functional programming, which is almost certainly not the languages you've used so far. You've probably learned Java or Python or maybe JavaScript, C++ or C#. These are all languages that, maybe Ruby, PHP. These are all languages that I wouldn't be surprised if you had studied already and written some code in. The language we'll be using is called Galena. It's in a tool called Coq, C-O-Q. And it is really, really different from what we're used to. In the next few videos, I'm going to show you how to get Coq and the various tools we need installed. And then I'm going to show you how programming in this language works. It's going to be pretty different. One thing that I want to stress up front, so here is the tool that we'll use. And we have the first day's file open. So what I want to do is go straight to the end, and there's a section here that says, that's like advice on how to succeed in the course. So this is going to be my closing thoughts for this video, and then we'll move on and talk about some more concrete stuff. Okay, there's three things. One is read the book, right? Each one of these .v files, each one of the files that we're going to do for each day, this is the textbook. It's very tempting to skim and just do the homework that's kind of in line with the textbook, but that is a bad idea. So the way you really want to work is you'll read the file, right? You can read through the chapter here as a file. We also have links to the book online. So the book here, if you go and click read, you can say, oh, show me the intro day. And it'll be the day sort of written up a little more nicely. Here's the same text. Oh, this is supposed to be bolded or something. I'll try to fix that. So however you want to read it, that's totally fine. But don't just skim. You want to read the chapter without doing any work just to get a sense of where you're going. You can skim it. Then maybe watch the videos and then interleave videos and problem solving, sort of having looked at the chapter, you know where you're going. It's really important to sort of like budget your time. And related to that is the next thought, don't spin. This is a very common problem in the course, is that students will get stuck, typically on a proof, but sometimes on a definition. We'll only be doing definitions at first. And you'll get stuck. You just can't get Coq to accept your program. It just refuses it. So it's actually a really, really picky system. It will not accept anything, say that, it won't accept programs that don't terminate, right? Which is sort of pretty different from the programming languages you've seen so far. So you just sit there, like what you'll do is you'll spin, you'll like for an hour try different things, and you're kind of like not directed, you're just playing around. It's what programmers call shotgun debugging. Never do this. So set a timer for like 10, 20 minutes. If that timer goes off and you haven't made progress, you haven't made like, oh, this is clearly moving along in the right direction, you need to stop. Go on Zulip, ask a question, say I'm stuck. Ask the question publicly so that other people can benefit from sort of seeing the answer too. Okay, lastly, I really want to normalize asking for help, right? It is normal to need help. Math and computer science are really hard, and they're even harder when you do them together. Like, the reason why we have TAs and me around is to help you do this, right? If you didn't need help, you wouldn't take a course, you would just read a book and move on. So you're in this course for a reason, right? Like the resources that you have include the people teaching the course, and I really implore you to use us as well as possible. So like, come to office hours, we'll have schedules for those soon. We need to work out what the what the right timings are. Come to office hours, go on Zulip. I am almost always on Zulip when it's working hours Pacific time, and often beyond that. So just go on, ask a question, just say you're stuck. I might poke you and say, oh, have you thought about this? And when you realize you haven't, I'll say, well, great, I'm not going to give you any more hints. Why don't you go think about that? That's still helpful in that now you're in the right direction. So I really think that coming early for help is really a very much a big deal. Okay, I think I've certainly talked enough about this. In the next video, I'll talk a bit about our tools, sort of how you get Emacs and Cock and Proof General, the tools that we'll need installed. We'll need one more tool much later in the course, but we don't need to install it now. And then we'll have some videos just about the actual course material. We'll dive right in. If you have any questions at all, do not hesitate to let me know. Zulip is the best venue. I will get back to you fastest that way. And also that way other people see your questions. So it makes it a little bit better than email. Okay, I think that's enough for now. I look forward to meeting all of you, and see you in the next video.